Okay, 4.3, this is actually the second part of it. Okay, yesterday we did polynomial long division. That will work all the time when you're dividing polynomials. Okay, polynomial long division will always work. Today we'll do synthetic division. That will only work sometimes. Now, when it does work, it is or tends to be much quicker. Okay, and you will also need to be able to do synthetic division for some things we're going to do down the road. Okay, so you will have to know how to do this. It's not one of those you can pick one or the other. Okay, you will have to know how to do it, because we will use it down the road. But it will be faster than polynomial long division in certain cases. Now, if they give me two things that they want me to divide, they give me negative x cubed plus 3x squared plus x, and they want me to divide it by x minus 2. Okay. The only time that you can do synthetic division is if you have a binomial like this. Okay? So as soon as I put an x squared in there, you can't use this anymore. Does that make sense? If this were x squared plus x minus 2, you can't do synthetic division. Okay? If it were 2x minus 2, or that wouldn't be so bad, or 3x minus 2, you're not going to want to do synthetic division. Okay, that'll be more difficult. But when it's a nice binomial like this, the coefficient on my x is 1. This is a nice whole number. Okay, or a nice integer. Then synthetic division is going to be the shortest route. Now, just like we did yesterday, if you're missing something, you need to fill it in with a 0. Okay, am I missing something here?
Yes.
0.
The x to the 0 power, right? Something at the end. I'm missing my whole number, or my coefficient with x to the 0. So I could write this as plus 0, correct? Okay, you're going to want to do that. You're going to want to make sure you do those things. So from here, and this is all going to be entirely new to you, okay? But I'm going to pull down the numbers that are in front of each of my variables. Okay, so in front of x cubed is
Negative 1.
Negative 1. In front of x squared is
3.
3. In front of x is
1.
1. In front of x to the 0 is
0.
0. Okay. Then we're going to draw, basically it's an upside down division bar, essentially. Okay.
Oh.
Does there need to be a space?
Yes.
Okay.
Good question. There does need to be space there.
So like,
I did that intentionally.
would you say 2
This
notebook
space here
paper?
is what she's talking about.
Would you
need
say
this space.
2 notebook paper lines?
1 would probably work.
Okay.
2 would be fine.
Okay, I did 1.
Yep. Don't need a ton of space.
Perfect.
Okay. Now the next thing we need to do is what this is. If I can divide this into this, that's telling me this is a factor of this. Okay, if it comes out as a whole number with no remainder. Okay, so I'm going to assume that this is a factor. If this was a factor, how would I find the 0 of this? I would set it equal to 0, and x would actually equal 2. Okay? This is the number we want to use in our synthetic division. We want to know, they give us this factor, we want to know what does x actually equal. Okay, so I solved this out, I got x equals 2. That's going on the outside here. Okay, so let's go ahead and say, let's say they gave me x plus 6. What would go out here? Negative 6. Okay, does everybody get where we're going with that? Mm-hmm. We're good there? Okay. Alright, so I have my 2 there. Okay, this next is just a pattern that we have to go through, and you're going to get really good at it. You're going to go through it quick eventually. Okay? The first thing you need to do is bring your negative 1 all the way down. and then I'm going to multiply -1 times 2. So 2 times -1 is -2. And then I'm going to add these together. 3 plus a -2 is 1. And then I go back and I do my pattern again. Now I'm multiplying times this number out here. So I have 2 times 1 is 2. And then what do you suppose we do? Add. 1 and 2 is 3. And now we're going to multiply. So I, excuse me, 2 times 3 is 6. Now we're going to add. 0 plus 6 is 6.
Where'd you get the 2?
Oh,
What 2?
This 2? Or the 2 I'm multiplying with?
The one you're multiplying.
From right here.
Can you just do that again?
We will. Okay, so I'm going to drag these out of here just to show you what it'll look like once you have that pattern all the way down. This is what you'll have. I brought down my -1. 2 times -1 is -2. I added 3 plus -2 is 1. I took 2 times 1 is 2. I added 1 plus 2 is 3. 2 times 3 is 6. 0 plus 6 is 6. Okay? You're multiplying diagonally, adding vertically. Okay? So now what this is, these are the numbers for my x squareds, x cubes, whatever it be, in my answer. Okay? But this is where people get confused. They try to start on the left side, and most people just automatically assume it's x squared and so on. Okay? You need to start on the right side. This is your remainder. So it's 6 over what?
X minus 2.
X minus 2. I technically divided by x minus 2, right?
Yes.
Okay, so 6 over x minus 2. I'm going to put a plus sign there because it was positive. This would be 3x to the what power?
First,
You're missing one.
third.
It's x to the 0. Remember, x to the 0, you're always going to have an x to the 0. So you have your remainder, x to the 0, meaning there's no visible x, right?
Yes.
This is going to be x to the first. This is going to be x to the second. Okay, so if I were to rewrite this, I'd have -x squared plus x plus 3 plus 6 over x minus 2.
so anytime it has like x minus 2 or x plus 3, it'll work anytime.
Say that again.
Anytime like there's x minus 2 or
Correct.
x minus 1, it'll
Yes.
just work.
Yep. But if I'd have given you this, doesn't work now.
Okay.
Okay.
So, if you have like, if you divide it by like x squared minus 2, would that work or
No.
no? Okay. Is x squared minus 2 not a binomial?
Squared minus 2 is technically a trinomial
Okay.
because it's technically x squared plus 0x plus
Okay.
2.
Yeah. Alright.
Okay. It has to be a linear expression.
Oh.
How's that?
Okay, yeah.
It's got to
That
be an
makes
x to
sense.
the first.
Mhm.
It's got to be a linear expression. Okay. All right, so let's do another one of these. Let's do 3x cubed. Like I said, once you get this pattern down, you're going to be able to do it very quickly. I have 3x cubed minus 7x squared plus 6x plus 8 and we want to divide it by x minus 1. What was our first step? Bring down my coefficients from my variables, right? Okay, so I have 3, -7, 6, 8. Was I missing anything that I should have filled in?
No.
Nope.
No, we're good there. And then I draw my upside down division bar for synthetic division. What goes on the front?
1.
Positive or negative?
Positive.
Positive 1. Good. Anybody confused on how we got positive 1? Okay. Now what?
You bring down the 3.
Bring down our 3. Basically, that's just so we can get started, right?
Mm-hmm.
Okay, that's the only thing we're using that for. So now we can get going.
Multiply by 1.
Multiply, because I need to go diagonal. So 1 times 3 is
3.
3. Vertically, I
Add.
and I get
-4.
-4. 1 times -4.
-4.
-4. I
Add.
and get
2.
2. 1 times 2 is
2.
2. 8 and 2 is
10.
10. So to that point, hopefully you can see why that's much faster than actual long division.
Yes.
Okay, that's going to save you a ton of time. The mistakes usually come right here. If you leave yourself enough space, you can usually just fill your variables in right here and you don't have to rewrite it. What's special about this 10?
That's the remainder.
It's my remainder, so it goes over
X over minus
x
1.
minus 1. 2 has an x to the
0.
0. -4 then has an x to the
First.
first. 3 has an x to the second.
Bingo.
Okay.
Actually, really easy.
Yeah. Now here's one of the most commonly confused things. Both of these that we have done have ended up with an x squared as the highest exponent, right?
Yes.
That doesn't mean all your problems are going to have an x squared as the highest exponent.
Okay.
Okay, so don't just start on the far left and start putting x squareds. X squared, x to the first, it won't work out.
It's just because both of them.
It just, it was just coincidental that both of them started with a cube. Okay, yes, Cole?
It would only work if like all of the coefficients are filled out. Like if it's
No. If I did this,
yeah.
still work, except instead of -7, you'd have put a 0. Which would obviously change our answer here, but you get what I'm saying?
Yeah.
Yeah, you would have to fill it in. You got to fill in anything you're missing. Okay?
Okay.
So, the one I want you guys to try, I'll give you about 2 minutes to do it once I'm done. They want to divide 4x cubed minus 2x squared minus 5x plus 11 by x plus 2. I'll give you about 2 minutes. See if we can get that. Okay, so Zach, what was that? What was the answer?
4x squared minus 10x plus 15 plus -19 over x plus 2.
Okay. So that should have been the correct answer. Most of you were close. A couple of you just mixed up. The most common mistake I saw was you had -5 plus a -20. -2 times -10 is +20.
Mm-hmm.
And that was the most common mistake. Now, this is the correct answer for this. Okay? Now, a similar problem they're going to give you is they are going to ask you to evaluate the function f of x equals 4x cubed minus 2x squared minus 5x plus 11. Notice same function, right?
Mm-hmm.
Okay. They want to evaluate this for x equaling -2, or another way to write that would be f of -2. And those mean the same thing, right?
You just plug in x, right?
Okay. You're going to do it using synthetic division, or in this case, we're going to call it synthetic substitution. Okay. Just like Damien just said, usually when they tell you this and they say evaluate, you take that -2 and you plug it in, right? Okay. Obviously, the higher the exponent goes, the bigger this number gets, the worse the numbers get to work with, correct? Okay. So we're going to set it up the exact same way. Notice when you plugged, what did you plug into synthetic division when you did this?
0.
-2.
You used -2.
Yeah.
Notice this is
Well- We
-2.
made it equal to 0.
Okay? No, because remember we were trying to figure out what x equaled up here,
Yeah.
and then we plugged it in. They already told us what x equals. Okay? So you need to be careful. If they're telling you to divide and they give you a binomial, you're going to have to change that sign. If they tell you to evaluate and they tell you x is equal to this, then you're just taking this and plugging it in. Okay, so let's set this up. I have 4, -2, -5, 11. Do I have to fill anything in?
No.
No.
Okay, we're good. And I'm going to plug in -2. So far, this looks exactly like what you did on your paper, correct?
Yes.
Okay. It is all the exact same thing. You're just looking for a different answer. Okay? So instead of actually dividing, we're evaluating now. Same process though. Bring down the 4. -2 times 4 is? -2 plus -8. -2 times -10. -5 plus 20. -2 times 15. 11 plus a -30.
-19.
Okay? That's exactly what you got on the last problem, right?
Yes.
Okay? The difference here in dividing and evaluating, this is your answer for division. This is your answer when you evaluate. Just -19. Meaning, if you were to take that -2, plug it in for all your x's and solve, what do you suppose you would get? -19.
Why does that work?
Because it is division. It's all the same thing.
That's kind of cool.
Well, why does that work?
It's your remainder.
Okay.
That's cool.
Algebra.
That's cool.
Why not? All right.
I think that's pretty
I'm
sick.
just gonna accept it as a fact.
Okay? So, regardless of what they say, whether they do say divide or evaluate, you're doing the exact same process. You're just looking for different answers, right? If you're dividing, you're looking for a polynomial. If you're evaluating, you're looking for your one remainder answer. Okay? Also be careful. Dividing, you're going to have to change some things up here, right? When they say evaluate, they've already told you what x equals. You just need to put it over here. Okay? You have the rest of the time to work on the assignment.
Are you going to